Welcome back, students. Let's continue to the last lesson of the chapter 7, which is one-dimensional collision. 7.3 One-dimensional collisions. Before go further, let's understand about the collisions. There are two general types of collision in physics, which is elastic and inelastic collisions. So, what is elastic collision and what is an inelastic collision? Inelastic collisions occur when the moving objects collide and bounce after collision. For inelastic collisions occur when the moving objects collide and do not bounce away from each other or stick together or move with the same velocity. This is other example of elastic collision and inelastic collisions. So for elastic collisions, after collision the object move with a different speeds for both objects. For inelastic collisions, we can see that after collisions the car and the trucks move with the same speed. So the difference between elastic and inelastic collision is about after collisions. So what happened after collision? If after collisions the object move with a different speeds and bounce to each other, this is a elastic collision. If after collisions the object move with a same speed and stick together, so this is an elastic collision. Elastic collision. An elastic collision is a collision in which there is no net loss in kinetic energy in the system as a result of the collisions. Both momentum and kinetic energy are conserved. So, total momentum before collision equal to the total momentum after collision. Same as a kinetic energy. Kinetic energy initial equal to kinetic energy after collision. This is formula for momentum. Conservation of momentum. Momentum before collision equal to the momentum of the after collision. Same to the kinetic energy. So kinetic energy before collision equal to after collision. In the other words, is conserved. So for elastic collisions, momentum and then kinetic is conserved and different to the inelastic collision. Inelastic collision. An inelastic collision, in contrast to the elastic collision, is a collision in which kinetic energy is not conserved due to the action of the internal frictions. In collision of the microscopic bodies, some kinetic energy is turned into vibration energy of an atom, causing a heating effect and the bodies are deformed. So in elastic collisions, a collision where momentum is conserved but kinetic energy is not conserved. So this is same. Momentum before and momentum after is conserved, but no conservation in kinetics energy. So total momentum before collision equal to the total momentum after collisions. So in an elastic collisions, it has the same speeds because the object sticks together. So kinetic energy initial and kinetic energy after does not conserve. So it has a total kinetic energy initial collision, total kinetic energy after collision. Some of the kinetic energy is lost and changed to the other form of energy. So we can find the total kinetic energy loss by find the difference for total kinetic energy after collision and total kinetic energy before collision. Okay students, let's do exercise 7.3. Question number 1. A proton car of mass 1500 kg moves with a velocity or initial velocity is 30 km per hour along a straight road. The car collides with a stationary MyV with a U equals to 0, car of mass 750 kg. Both cars move together after the collisions. So what is the final velocity of two cars? Okay, you have to figure out the information given. So the first car is a proton car. Okay, proton car. Okay, proton car with a mass equals to 1500 kg, U equals to 30 km per hour, collide with a second car of MyV which is mass equals to 750 kg, and then speed is a U stationary. It's mentioned about the with a stationary is means that U equals to 0. After collisions or impacts, the car move together or stick together. Proton and MyV. Okay, and then move with a same speed V. So from this we know that N is an elastic collision. So from conservation we can use the conservation of momentum only. So total initial before collision equals to total momentum after collision. We cannot use the total kinetic energy initial because does not conserve total kinetic energy. Fine. So we use the conservation of momentum. Total momentum initial equals to total momentum after collision. So we try to figure out M1 M proton U proton plus M MyV U MyV equals to mass proton and mass MyV time to velocity, same speed of velocity. So we try to find the V, the speeds after collisions, substitute the value. So the value mass of proton 1500 times the initial velocity is 30 meter per second, 30 km per hour, and then plus initial speed of the MyV with a stationary U equals to 0, and then divide by mass of proton and then mass of MyV, and lastly you get the answer V of proton and MyV 20 km per hour. Exercise 7.3 question number 2. Okay, an object of mass 2 kg move at the velocity 10 meter per second collide head-on elastically with a stationary object of mass 3 kg. Determine the velocity of each after the collision. So we have two objects, object 1 which is mass equals to 2 kg, object 2 which is mass 3 kg, object 1 with a velocity U equals to 10 meter per second, and then object 2 with a stationary, so U equals to 0, collide, and then after collision head on elastically, so it moves with an elastic. So object 1 and object 2 with a v1 and then v2 with a different of v. So the question asks about the speed of the object after collision. Okay, how to answer these questions? So from this question, we read about head on, so it's elastic collision. So when elastic collision, total momentum initial equals to total momentum after collision. So same to the kinetic energy, total kinetic energy initial equals to total kinetic energy after ataupun final. So we have to come out the equations. It maybe have the two equations. So for momentum, conservation of momentum, total kinetic energy, total momentum initial equals to total momentum after, which is m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. Okay, continue. So m1 is 2 kg, 2 kg, then their speed is 10, plus m2 is 3 kg, their speed is stationary is 0, equals to m1 is 2 kg, v1 plus m2 is 3 kg, 3 kg times v2. So 20 2 10 10 is 20 equals to 2 v1 plus 3 v2. We can put the v1 at one side. 2 v1 equals to 20 minus 3 v2, or v1 equals to 10 minus 1 over 5 v2. Okay, this is equation number 1. Okay, for conservation of conservation of kinetic energy, total kinetic energy initial equals to total kinetic energy after. So total kinetic energy equals to half m1 u1 square plus half m2 u2 square equals to half m1 v1 square plus half m2 v2 square. So we can substitute the informations. So half m1 is 2 and 10 out of 2 plus half m2 is 3, initial speed is 0, plus half 2 v1 square plus half 3 v2 square. Okay, get it? After this, the all term is a half, so you can cancel it out. So 2 10 10 power of 2, so we can get 200 minus 0 equals to v1 square plus 2v1 square plus 3v2 square. So 200 equals to 2v1 square plus 3v2 square. Question number 2. And then question number 1 is v1 from previous slide. v1 equals to 10 minus 1.5 v2. This is question number 1. This is question number 2. So we substitute equation number 1 to the equation number 2. So we can get 200 equals to 2 v1. We substitute v1 square, then minus 1.5 v2 square plus 3v2 square. So we expand, so 200 equals to 2, 100 minus 30 v2 plus 2.25 square plus 3v2 square. Okay, expand again, 200 equals to 200 minus 60 v2 v2 square, okay, plus 4.5 v2 square plus 3v2 power of square. So we can get 200 minus 200 from the right equals to 60 minus 60 v2 plus 7.5 v2 square. So we cancel, 0 equals to negative 60 v2 plus 7.5 v2 square. So from before, 0 equals to 60 minus 60 v2 plus plus 7.5 v2 square. So we put in the one side, so 60 v2 equals to 7.5 v2 square. So and then we can get v2 equals to 8. So the v2 is 8. Okay, how to get the v1? From the equation number 1. So equation number 1 is v1 equals to 10 minus 1.5 v2. So v1 is 10 minus 1.5 times v2 is 8. So v1 we can get 10 minus 12, and then v2 we can get negative 12. So for the objects, so speed velocity of v1, sorry this is v1's velocity of object 2 kg is negative 2 meters per second, and then velocity of object 3 kg after collision is 8 meters per second. Okay student, we are done for chapter 7. Thank you for your attention. That's all for this semester. Do a lot of exercise and good luck in your test too. Bye bye.